In this example, we want to find the roots of the polynomial p of x equals 3x cubed plus 2x squared minus 7x plus 2. In other words, we want to find solutions to the equation 3x cubed plus 2x squared minus 7x plus 2 equals 0. We saw that to find the rational roots, we use the rational root theorem. That says if p over q is a root of the polynomial p of x equals an x to the n all the way down to our constant a0, then p divides a0 and q divides an. For this particular p of x, we have that our constant a0 is 2 and our lead coefficient a3 is 3. This means that p has to divide 2 and q has to divide 3. So the possible values of p are all the numbers that divide 2, plus or minus 1 and plus or minus 2, while the possible values of q are all the numbers that divide 3, plus or minus 1 and plus or minus 3. So the possible values of the roots p over q are all the possible combinations of p from our first list over q from our second list. First, we could have that p is plus or minus 1 and q is plus or minus 1, which gives the fraction plus or minus 1 over 1. We could have plus or minus 1 for p and plus or minus 3 from q, giving the combination plus or minus 1/3. If p is plus or minus 2 and q is plus or minus 1, then p over q would look like plus or minus 2 over 1. And finally, we could have that p over q is plus or minus 2/3. Now these are all the possible rational roots for our polynomial. But we need to evaluate p of x at our possible roots to see which ones are actually roots. We know that since this is a degree 3 polynomial, that at most 3 of them will actually be roots. So to find which ones are roots, we need to evaluate our function at all of these possible roots and see which ones give us 0. Since there are so many values to check, it'll be useful to do this with a calculator. If we evaluate at x equals 1, we find that p of 1 is 0. It's actually one of our roots. But when we evaluate at x equals negative 1, we find that p of negative 1 is 8, which is not 0, and that's all we care about. So negative 1 is not one of our roots. Evaluating at 1/3, we find that p is 0. Evaluating at negative 1/3, we get 40 over 9, which is not 0. And evaluating at p of 2, we get 20, which again is not 0. But when we evaluate at negative 2, we get that p of negative 2 is 0. We could stop here because we have found that p of 1, p of 1/3, and p of negative 2 are all roots. And since this is a degree 3 polynomial, we know from the fundamental theorem of algebra that p of x can only have 3 roots. So we know that these 3 roots are the only 3 roots. And we don't even need to check p of 2/3 or p of negative 2/3 because we know they can't be 0. So we can conclude that the roots of p of x equals 3x cubed plus 2x squared minus 7x plus 2 are the values negative 2, 1, and 1/3.